Welcome to our session on Math Snacks. My name is Sara Morales, and our co-host today is Ruth Torres Castillo. We are from New Mexico State University. We're going to start our session today with open gameplay for a game we created called Curse Reverse. Please join us at www.mathsnacks.org and play with us. We'll explore for 5 minutes. So in this game, students get to explore through different rooms. We see Ruth going into room number 1. If you see, there's a slide bar to the left with a variable equal to 6. So Ruth is trying to get the character to that tower, but it seems like it's a little bit too high. So we can slide up and down to change the value of that tower. Now we need to jump up and get the character through the door. And this room has been completed. Then students can go to room 2. Here I see that n has a value of 2. But I'm wondering, Ruth, what would happen if you try from there, right where you're at? Can you jump up and get through that level? It doesn't seem to work. So what needs to happen is that the character can only jump 1 square away from where he needs to be. So if you're too low or too high, that can't work. So we will need to change our value to 3. In this level, I'll talk to you about those treasures. If you notice, we saw some shiny treasures. They kind of look like flowers, maybe. We need to make sure that students collect those treasures and put them back to where they belong. So Ruth will show you how to do that. If you notice right now, she had to pass the treasure to get through the water. And now she will need to bring the character back up and over to collect that treasure. Can you show us, Ruth? And now, remember what we talked about? She can only be 1 above or below, so that's why she couldn't jump up to that top level, but she can go back. And play with those variables so that we can get them to where they need to be. So what's happening here is that the tower is too high. If she jumps right now, she will fall. So we need to go back and change the variable to a better number. The game keeps record of how many treasures you have, so many moves you've done. In this case, she returned all the treasures, all the bonuses, and she also had 5 or fewer moves. The students will at first make a lot of moves, and that's okay. They may fall and they'll have to start again, and that's okay, because right now they're just exploring. In this level, we don't need to pre-teach anything about variables. You don't pre-teach anything about evaluating expressions. The students are just getting familiar with the gameplay. How do we move the character? How many times do we need to jump? What does this treasure do? What happens when I don't move the sliding bar to the correct number? What happens if I fall? They'll start discovering things about the game, but not necessarily focus on the math, and that's okay. This is why we start with only exploring. Just let them play the game. Now that you got excited about Course Reverse, I'll let you in on a little bit about Math Snacks. Math Snacks is funded by the National Science Foundation, and we've been around for about 10 years. These games and animations were developed at the university, but with the user testing of students and feedback from teachers at every level of game development. Our Math Snacks website, mathsnacks.org, provide teachers with the tools they need to teach games and animations. That includes teacher guides, printable student guides, hands-on activities to complement the games and the animations. And my favorite is teaching with videos. For every game and every animation, you will find a short video that teaches you how to teach with Math Snacks in real time with students. So you get to observe a mini lesson per se before you actually implement the games or animations in your classroom. You see how it all comes together, and your students will have a great time. Please make sure to explore our website. But we'll continue with Course Reverse now. Now, keep in mind that when we developed all of these tools, we didn't expect for teaching to be solely online. So we're coming up with better ways to make it accessible online so that you can play with your students using any scenario. Our research has shown that after you allow students to play the games, it's very important to reflect and discuss what they have played. We have created some questions to allow for this discussion piece to take place. Talk about the game. Ask students, what did you like about the game? What makes the game challenging? What were some of the strategies that you used to achieve getting the character through the door? You might even ask them to play the game the night before and then come back and discuss the strategies that they use and what they found out about the game. With our teacher guide, you will have about 8 questions that students will use to discuss and talk about the game in a way that feels comfortable for them and in a way that gets them excited to learn the math and to play again. The third step is to play the game again. After students discuss for about 10 to 20 minutes, we found out that it's very helpful for them to play again so that they focus on the things that they didn't see before. For example, what do the stars mean? How many moves did it take for them to complete one level? So students can go to breakout rooms if they can. If not, they can play on their own and just show their screens after they play so that we can start seeing their progress. What rooms did they explore? Did they get those achievement stars? The second gameplay really gets them excited to start talking about the math needed to be able to complete the different levels. Our fourth step is a supporting activity. We want kids to start exploring with variables and expressions. You see those beautiful pictures? Students, when they're together, they really get into playing with cubes and playing with numbers, talking about variables and applying those key concepts. To do this activity online, we've prepared some things for you using Jamboard, and let's go and explore those next. If you haven't seen Jamboard before, Jamboard is a collaborative tool used to bring students together so that everyone can be working at the same time. So for this activity, we first have to use dice, and we will roll the dice, and I had a 6, a 5, and a 3. So those would be my variables. The 6 would be my variable A, the 5 is variable B, and the 3 we'll use for a constant. That will be C. In this key, we don't have a C, so for right now, I will not be using a 3. So let's go into Jamboard and see how this all comes together. Variable A is equal to 6, but I want students to see what that looks like. Can you show us, Ruth, using the Unifix cubes?
Yes.
So if A is equal to 6, that means that I can create a tower of 6. Now that I have 6, my tower can never be broken. The 6 never breaks apart. So I have 6, but I notice that my coefficient was 4. That means that I have 6 4 times. So what would that look like, Ruth?
6.
If I have a tower of 6, I would need a second tower of 6, and maybe we can use the cubes or we can use the pencil. This is my second tower of 6. And then I need a third tower of 6. And a fourth tower of 6. So notice how my tower of 6 will never break, just like in the game. The students will be able to see that as they're playing through the different levels. Okay, now let's go back to my key and see what this looks like. Now I had 4 towers of 6, which gives me 24 or 24 cubes. Now I'm just picking any number to write as my coefficient for B, but B is equal to 5. If I have 3 towers of 5, I will end up with 15 cubes. 24 minus 15 is equal to 9. So the value of this key will be 9. Let's go over this again. My variables from my die were 6, 5, and 3. I will not be using 3 today because we don't have a constant in our key. So to evaluate for A, that means that I have 4 towers of 6, giving me 24. To evaluate B, I just picked any number, and I have 3 towers of 5, giving me 15. 24 minus 15 is 9. I'm going to have Ruth show us the next slide, where we can use this key to open a lock to uncover a secret message. Oh, but look at what happens. I don't have a value of 9. So that means that my key did not open any of these locks. Let's try again. Remember, the 6 does not change. The 5 does not change. So I want to change my coefficient and then evaluate my expression in a different way. If I have 4 towers of 6, I will end up with 24. 4 times 6 is 24. And then I want to do, say, 2 towers of 5. 2 times 5 is 10. 24 minus 10 will give me a value of 14. Now let's go to the secret image and see if we have a 14, and we do. You can remove that lock and show students part of the secret image. Once the students get all of their numbers, we will have a beautiful image revealed. We've recreated the handout using Jamboard. The objective is to evaluate expressions so that students can unlock the numbers to reveal a secret image. Students can use the keys handout and evaluate their own expressions to come up with the different numbers to open the different locks. If you see here, we're getting a little bit more complex where they do have a constant C. And here they have a blank key so that they can come up with their own expressions. But remind them, the variables and the constant from when they roll their die never changes. This is what the handout will look like as a printable, or you can use Jamboard to make it more interactive if you're working online. Here we have the secret image all revealed. That means that everyone found all of those numbers, and you can just click on the number and it will slide out, so it's easily available for you in a PowerPoint version. This activity allows students to take ownership of their own learning. Now they have played the game, they have done an activity which has engaged them in having to think about variables and what it means. What does it mean to evaluate an expression? And they have manipulated different numbers. Now they're ready to play the game again. The first round, they played with the purpose of just exploring the game. In the second round, they started exploring with things about the game they did not know before. In this third round of gameplay, they're really going to delve deeper into the math and that conceptual understanding of variables and expressions. So let's review the 5 steps for supporting game-based learning online. The first step is to play the game. Let them explore, let them have fun. You don't need to pre-teach anything. You don't need to teach vocabulary. You don't need to pre-teach about X or Y or variables or expressions. Just open the game up like we did for students to play. Step number 2 is reflect and discuss. Now, we do understand that you may not have your typical face-to-face real-time setting. You may be working with whole groups of students online. You may be working right now with small groups, or you may not have access to doing Zoom at all with students. So how can we reflect and discuss in the virtual times that we're living now? Well, we can have students talk to parents. You can have students talk to the teacher. Maybe you ask them a question via email and they reply to you. Or maybe if you have a Google Classroom, you will post it as a discussion question. So try and find ways where students can continue to have that discussion and help each other with those strategies, because reflecting and discussing is an important part of gameplay. Students should not just play and play alone. They need to have a space for them to talk about the things that they found out and to talk about those strategies so that later on their conceptual understanding of mathematics comes together. Another way is having students share with each other. If your district allows, students can go into breakout rooms. Students can be placed in pairs. An idea would even be play at home and talk to each other on the phone, and then make a report on the different strategies that you use to play the game. Students can also talk, which would be ideally in the classroom. And if you can see in the picture, this is one of our wonderful teachers who annotated everything that they talked about while they were discussing whole class. Zoom also has different tools for you, like the chat, the breakout rooms, all the annotation tool, all which can be used to help students discuss in an online setting. Step 3 is to play the game again. And remember, this time students will explore things that their friends explored. They will see things that they did not see during that first gameplay when they were simply exploring. They're really building those gameplay skills and they're getting better with the mechanics of the game. During the supporting activity, students will bring forth the mathematics of the game. This is really when they take ownership of what it means to manipulate variables and expressions. If you saw when we played, they can visualize A equals 3. That means that 3 stays the same every single time. If you have 3 groups of 3, you will see 3, 3, 3. You could never break that 3. If you have 5 groups of 3, you will see 3, 3, 3, 3, 3, 5 times. So have them explore with the activity and have them talk about it and have fun with it. If they are having a hard time coming up with the right numbers, pair them up. Talk about, well, do you need to lower that coefficient, or does the coefficient needs to be higher so that they can get to the target number, say 12. The supporting activity pushes students into that last gameplay session. The last gameplay session brings everything together. During this session, students will start asking for paper pencil. They are going to want to start evaluating these expressions before going into the game. They're going to want to get through the game with the least amount of moves. And they're really building that conceptual mathematics of what happens when you have variables and when you have standalone numbers. They will bring everything together in a way that makes sense for them and in a way that builds the conceptual mathematics. I hope that what we've done here is helpful to you in your classroom. Please let us know how we can be of support to you. Please play the game with your students and provide us with the feedback. You can email us at smorales@nmsu.edu, or you can email ruth@rutorres@nmsu.edu. Have fun with Math Snacks, and we will love to hear from you. Thank you.